Good evening to one and all present here. I am Kavya ADE, second year BME A section. I talk about the topic of analyzation of digital of clocking sequence structure. Introduction. Introductions of sequential structures. What is the sequential structure? Unlike combinational logics and output depends upon the both current input and the past sequence input. They are mainly elements flip-flop to store the state. Clock sequence circuit. Clock sequence circuit is also known as synchronous sequence circuit. State that state are synchronous by based time signals known as the clock pulse. This is a block diagram of the clock sequencer circuit. First we apply the external input. It will throw the combinational logics, and then next memory elements flip flop. Next output will be and then output. The memory elements in the current status feedback. And then the role of clock in sequential circuit. Synchronizations of timing. The clock ensure all memory elements update stimulation simultaneously. Prevent timing hazards and outputs. Either the reasoning aids positive aids, falling aids negative. Falling aids means negative, reasoning aids means positive. This is a block diagram. First we throw the reasoning aids, low start, and the clock signals waves. Falling aids, high start. Core memory element, that means flip flop. Building blocks, it is a flip flop. D flip flop. Output followed to the input at the clock aids. Most common modes designs. JK flip flop can set, reset, hold the state base of the J and K input. T flip flop. D means data. T flip flop. Start if T is equal to 1, hold if T is equal to 0. This is the D flip flop and JK flip flop. Diagram of D flip flop and JK flip flop. Understanding state diagrams and tables. State diagram, state table, Marial model. State diagram, the graphical representation of the sequential circuit. Circle represents states. Directed arrow represents state table, the tabulation of the state diagram listing present state, input, next state and output. Marial model, output depends upon the and input. Arrow show input and output. Marial model, output depends upon only on the state. Circle show state and output. State diagram example. Marial state diagram. 101 sequence state. 101 sequence deduction. This state diagram depicts the sequence 101 in the continuous input stream. State SO reset and start. S1 found 1, S2 found 10. These are all the block diagram. Analyzed production. How to analyze the clock sequence circuit? Step 1. Deduct the Boolean expression for the flip-flop input and circuit output for the logic diagram. Step 2. Drive the next state equations by the input equation in the characteristic equation of the flip-flop. Step 3. Step 3. State table. Step 4. Draw the state diagram and understanding the circuit function. Next, circuit analysis example. Analyzing a simple D flip-flop circuit. Input equation D is equal to A plus Q. Input A XOR current state Q. Next, the equation for D flip-flop. D is D into T plus 1 equal to Q into D plus 1 equal to D. Therefore, Q into T plus 1 is equal to A into Q. When A is equal to 1, the circuit is state on every clock pulse. When A is equal to 0, it holds the state. First we apply the A input. Next, XOR gate and flip-flop D flip-flop. We throw the clock into the D flip-flop and the XOR gate throw the D flip-flop and feedback path. Design production. Designing a clock sequence current. Step 1. Specification. Step 2. State diagram. Step 3. State table and reduction. Step 4. State assignment. Step 5. Choose the flip-flop and extension table. Step 6. Logic gates. Specification. Under the behaviors. Step 2. State diagram. Draw the required transition. Step 3. State table and reduction. Create the table and eliminate state to minimal hardware. Step 4. State assignments. Assign binary code to the step. Step 5. Choose the flip-flop. Choose D, JK and T flip-flop. Determine requiring inputs. Step 6. Logic diagram. Use K-map to simplify equation and draw the final circuit. Thank you.